Hi everybody, in this video I'll be talking about how to factor trinomials. Factoring trinomials involves quadratic expressions such as this one, where we have two coefficients a and b, and we have a constant, obviously, by the letter c at the end. So this is an extension of slope-intercept form from algebra A, where we deal with y equals mx plus b. Now we're adding an extra term at the beginning called ax squared. So by raising that power of 2, it affects the graph outcome. But that's in another video. In this one, we are simply concerned with factoring this trinomial into two binomials. Okay, so ultimately the outcome of this, if it is possible to factor, the outcome would be to take all this and transform it so that what you end up with are two binomials. That's our ultimate objective. So having said that, let's go ahead and look at our example. There are about 6 steps that I intend to take with this, and I know that there are other styles out there, some of which are a lot shorter, but the reason I take 6 steps to do it is because I feel it taps into prior knowledge regarding combining like terms and factoring GCFs from an expression, which I think are very valuable to hold on to. So having said that, here's our first example. So we're going to factor p to the second power plus 3p plus 2. Now to do this, the first step would be to identify the a, b, and c values. Now if you remember from our expression up here, a and b are both coefficients and c is a constant. So let's see, if we look at our expression here, our a value would be a 1, which is right there. So I can say a is 1. I can also say that my b number is 3, which is right here. And our c value, is 2, which is at the end. So that's step 1, just identifying those numbers. Now step 2 is taking our a and c values and multiplying them together. Now if I were to take a times c, what I would get is essentially 1 times 2, which is 2. And I'm going to put this next to our b value, which is a 3. Now my purpose in step 2 is to see what two factors I can have that make a 2, and those same factors also create a 3 by adding and subtracting. Being a 2 makes it easy because that's a prime number. So only 1 times 2 makes a 2, and if I test it out, 1 plus 2, does that equal 3? The answer is yes. And because the answer is yes, we're going to now use our 1 and 2 in step 3, which is to split our bx term, which is the middle term, into two like terms made up with our factors. So if we go back to our expression, over here we have p squared plus 3p plus 2. So I'll put that over here, p squared plus 3p plus 2. And we will represent our middle term, our 3p, as a combination of 1p and 2p. Again, 1 and 2 come from our factors which we figured out over here. The first term and last term fall in line. So p squared plus 1p plus 2p plus the 2. Okay, and that is step 3. Step 4 is to create two binomial groups using parentheses. Now I have over here in step 3, I have a polynomial. I have 4 terms involved here. If I want to make two groups using parentheses with 4 terms, it's easy. Just put 2 terms in one and 2 terms in the other. What I mean by that is this. So I will simply have p to the second power plus 1p. And I'm showing this again as a representation of combining like terms. So it would be plus and then 2p plus 2 in the other. Again, you have to show that this 1p and that 2p are combining to make the 3p. So having said that, I'll actually stay true to our color here. And we have red, so this would be 1p, this would be 2p, and this is a plus sign. That's step 4, okay? Two binomial groups using parentheses. Step 5 is factoring the GCF from each group. Now, in the first group, we have to look at what we have in common. So the GCF, the greatest common factor, in the first group would simply be a 1, and then a p, because they both have a p. So 1p. In parentheses, what I have left over would be a p plus a 1. In the second group, 2p and 2, I can factor out a 2, and that would leave a p plus 1. Now, you might notice at this point, hey, these two binomials in black, they are identical. Yes, and at this stage, they need to be. So that's a good marker for whether or not you're doing this correctly. If they are not different by step 5, then something's wrong, and you have to go back and check it and fix it. Okay, step 6, where we put it all together. So it may not look like we are about to finish, but we are. So what we're going to do is we are going to place what we have into these two binomial groups, and we're done. So they both have a p plus 1 over here. So I'm actually going to factor out an entire p plus 1 group. So p plus 1. And in the other group, what I have after I factor out p plus 1, I have 1p plus 2. And with that, we are finished. So we have two binomials which are now multiplying. And if I were to apply 3 methods of doing this, which is the box method or square method, stack them up, or if I were to distribute using the formula method, either method would give me back what I started with, which is p squared plus 3p plus 2. Okay, that's our first example. Let's move on to the second example and see if this gets any easier. So in the second example, we have a negative involved, so we have to be a little careful, but it starts the same way. So I have to identify A, B, and C. A is 1, so A is 1. B is 2, B is 2. C is negative 15. That negative does matter, so make sure you include it with the number. So it's negative 15. Step 2, multiply A and C together. So, all right, A times C in this case would be 1 times negative 15, negative 15. And then I need to compare this with a 2. Now, I have to get factors of negative 15, which also add or subtract to make a positive 2. So this is about guessing and checking at this point. So let's see. 15, the only numbers I can think of that multiply to make 15 and possibly a 2 would be 3 and 5. Now, I need to make a negative 15. So one of these needs to be a negative. So let's try to put the negative on the 3. And if I do that, what I get is negative 3 plus 5. Now, would negative 3 plus 5 make, would it make a, excuse me, go away. There we go. Would it make a positive 2? The answer is yes. And because it makes a positive 2, what that means is that I'm going to use my negative 3 and my positive 5. So on to step 3. In step 3, I'm going to take my polynomial, which is a squared plus 2a minus 15. I'm going to take that, and what I'm going to do is a squared plus 2a minus 15. What I'm going to do with that is I'm going to split the middle term to represent 2a as a combination of negative 3a and 5a, okay? Negative 3a plus 5a makes 2a. Now, the leader of this group, which is a squared, comes down, and the n, the constant, also comes down. And that's the end of step 3. Now I have a polynomial with 4 terms, and I'm going to make a group, 2 groups of binomials by inserting parentheses in there. And what I would get is the following. I would get a squared minus 3a, that's one group. I must put the plus sign in the middle because I'm still showing that these 2 terms, negative 3a and 5a, combine to make the 2a. So plus parentheses 5a minus 15. Okay, now that's the end of step 4. Step 5 is to factor a GCF from each of these two binomial groups. So we'll start with this one over here. I notice that I can factor out a 1, but I also notice that they each have an a. So I can factor out 1a at the most. That leaves me with an a minus 3 from the first one. From the second one, they both have they are both odd numbers, and 5 goes into both, so I can factor out a plus 5. That leaves me with an a minus 3. Now, like I said in the last example, at stage 5, you need to have two identical binomials at this point. And if they are identical, you're doing everything correctly. So let's move on to step 6, where we finish everything up. So we take the red components. We're going to factor out the a minus 3 from both of those red components. And what's left after I factor out the a minus 3 is just 1a plus 5. And that would be the end. So I have successfully factored the second trinomial. Okay, so if you were to multiply these two binomials together, what you would get in return, you get this back again. Okay, you get that back. In fact, in the few minutes that I have left for this video, I want to go ahead and do that just as an answer check, so you can see, whoops, too far. You can see that this actually does work, okay? And there is a connection. So let's go ahead and do that. We're going to apply the distribution method for this, also known as a FOIL method for some of you. So multiplying those would give me the following. This would be a to the second power plus 5a. Then doing the same thing but going under. So negative 3 times a, negative 3 times 5 would give me the following. It would be, sorry about that, it would be negative 3a minus 15. And as you can see, I have my 5a and I have my negative 3a. And that, if you look back over here, 5a and negative 3a, there it is, 5a, negative 3a. From step 4, 5a and negative 3a from step 3, when we first split that 2a. And the 5 and negative 3 themselves come from factors of negative 15, and that was in step 2. Okay, so everything does connect. Now, if I were to combine the terms in the middle, what I would then get would be the following. It would be a squared plus 2a minus 15. And if you look carefully, that trinomial is exactly what we started with. I'll swing over to the left. There it is, a squared plus 2a minus 15. It's a perfect match, which means that what I did all the way to the end is correct. So the purpose of factoring is to recreate the binomials that, when multiplied, make the trinomial. So it's essentially the opposite of distribution. So factoring is the opposite of distribution in the same way that adding is the opposite of subtracting and multiplying is the opposite of dividing. So hopefully this video helped you out. Look for part 2. There will be 2 more examples of how to factor trinomials when your a value is bigger than a 1. Okay, so I hope this video helped. Please stop by, leave a comment, and as always, thanks for watching. Bye-bye.